now that we have a solid grounding in logic, we're going to start trying to apply these ideas to something. And so we're going to move into proof. So these will be our first steps towards proof. However, we're going to start with something that we already know how to do. And so that thing that we already know how to do is algebra. So we will be starting with algebraic proof. So what we're going to be doing is basically working through some algebra problems, but for every step that I do, I want to be able to give a reason. And so my reasons, in general, whenever I write proofs, will come from postulates or theorems that we have, or definitions, or properties. And so the main thing that we're going to be using are properties in this situation. So we need to talk about what properties that we can use. So the first set of properties that we're going to talk about are called my properties of equality. So these are my properties of equality. There are a few of them. Properties of equality. And each of these will be a reason that I can give for justifying why I'm doing something. So my properties of equality, well, the first one is the addition property of equality. The addition property of equality just tells me that if I have an equation where a is equal to b, what I'm allowed to do is add a number to both sides of the equation, and it still remains a true statement. So if a is equal to b, then I can, of course, add some other number to both sides of this equation, and it's still a true statement. So that's my addition property. I can do the same thing with subtraction. I have a subtraction property of equality. And it says pretty much the same thing, just for subtraction, so that if a is equal to b, then I can subtract something from both sides of my equation, and I still get a true statement. I guess I really shouldn't put a period. The next one is the multiplication property of equality. And as it might surprise you, it says that if I have an equation where a is equal to b, I can multiply both sides of my equation by the same thing, and I still get a true statement. So in this case, a times c is going to be equal to b times c. I also have the division property of equality, which says the same thing with one small addition. If a is equal to b, then a over c is equal to b over c, and that's only when c is not equal to 0. So that's great. And then I have one last one. So these are my 4 operations. These are pretty straightforward. You've been using these for a long time. But then I have another one, which is my substitution property, and this is a little bit of a weird one to write, but just says that if I have two things that are equal to each other, if a is equal to b, then a can be substituted for b. So these are my 5 properties of equality. I have my 4 operations here, and there's nothing shocking. It just says that whatever I do to one side of an equation, I have to do to the other. And then my last one here is my substitution property of equality, which just says that if two things are equal to each other, I can substitute one in for the other in the equation. And so then my last property that I want to talk about, which is not a property of equality, is just the distributive property, which says that if, well, really it's not even an if, I'm not going to write it as an if, it just says that whenever I have some number times some other pair of numbers being added together, what that'll be equal to is just that distributed out, so a times b and b times c. I don't have a different one for subtraction, obviously, because this could just be talking about a negative number here or here. So these are my 6 properties in total that I have. that I'm going to use to justify the algebra that I'm doing. Again, nothing new, nothing shocking here. You've been using these for a long time, just maybe haven't been calling them by these things. So let's see what this looks like then. Let's make this all go away. And okay, let's look at an example. Let's just look at a real basic equation that I want to solve. Let's say I want to solve the equation 2x plus 5 is equal to 20 minus 3x. Okay, so something not too bad. So here's what I'm going to do. I'm going to solve this, but give justification as I go, and I'll put this all inside of this t-chart here. And so on one side, I'm going to give my statement, so what I'm actually working with. And on the other side, I'm going to give my reasons. So why am I able to do the thing that I'm doing? So I'm going to number these as I go. The first thing that I'm going to do is I'm going to just write down the equation that I have. 2x plus 5 is equal to 20 minus 3x. My reason for that seems kind of simplistic. It's just that it was given to me that this was true. So next thing I want to do is, well, how do I solve this? So I have to think back to my algebra days, and I just need to, let's just put all of my x terms on one side. So let's add 3x to both sides. Now it's going to seem a bit tedious, but that's okay. I'm going to add 3x this side. I'm going to add 3x to this side. And what allowed me to do this was that I took my previous equation, my previous statement that I had, and I just added 3x to both sides. So this is my addition property of equality that allows me to do this thing. I'm using the previous statement, I'm adding something to both sides, I'm getting this new statement. And so next, I am just going to simplify what I have. So 2x plus 5x, or sorry, 2x plus 3x is 5x, plus 5 is equal to, and then 3x minus 3x is just 0. Perfect. So now, what's my reason for that? This is just simplification. It's not really a great reason, but I'm just adding my like terms together and simplifying, no big deal. Okay, next thing. So how do I want to solve? Well, now I need to get this 5 onto the other side. I need to get all my constants on my right side, so I'm going to subtract 5, or just 5 from both sides. 5x plus 5 minus 5 equals 20 minus 5. I've subtracted 5 from both sides. And so what does that mean? My reason was, well, if I subtracted something from both sides, this is my subtraction property of equality. Great. So I'll simplify this again. And I will get that 5x, so 5 minus 5 is just 0, is equal to 20 minus 5, which is 15. What did I do here? Well, this is just simplification again. And then my last couple steps here, I need to solve for x. So how do I solve for x? Well, I need to divide both sides by 5. I divide this side by 5. I'm going to divide this side by 5. What allows me to do that? This is my division property of equality. And then last but not least, I'm just going to simplify this. So 5 divided by 5 is just 1, so I'm left with x is equal to 3. This is 7, and this is my simplification step. Alright, so I know this is a lot more tedious and a lot more work than how you would normally solve an equation, but it's not really the algebra that I'm caring about right now. What I'm caring about right now is just this process of every time I do something, I should be able to give a reason for it. And so actually, if I look back here for a second, every statement that I make is a connection of the previous statement and then the reason that I'm given. So if I have an equation, what did I do? I added something. I used the addition property of equality to get my new equation. And I took my previous statement and I simplified it to get my new statement. And then I took my new statement here, I subtracted something from both sides to get my new statement here. And I could keep going down the list here, but every statement I give should be connected to a previous statement that I have via the reason that I'm giving. And so this is what proof's going to look like for us. We're just trying to do some really basic examples that are just using algebra, but this is how we prove things. We connect statements to new statements using reasons.